Good morning, everyone. This is Joy Allen. I am a Customer Success Program Manager for NetApp out of their Michigan office. And I just wanted to welcome everyone to today's meeting. Kyle Kuntz is going to be talking about regular expressions, and I'll go ahead and turn it over to him to let him introduce himself. Thanks, Kyle.
Thank you, Joy. Thank you guys for taking the time out of your day to hop on our weekly webinars. So as Joy mentioned, today we'll be focusing on regular expressions. So I'm Kyle Kuntz. I'm one of our NetApp Customer Success Managers, and been with NetApp for about 7 years now. Just to go over the agenda for today, so we're going to spend a little bit of time going through a recap from our Device Resolution 101. For those of you that weren't able to make it or watch the recording, B, just to kind of refresh some of the concepts before we jump into going through some regular expression examples. So I then have 4 different examples I want to go through, spend a little bit of time on each one, make sure you guys don't have any questions. I do have some resources at the end that will provide quite a few more. Afterwards, I want to spend some time going through setting up auto-resolution rules using regular expressions to be able to capture device information or identify devices. And then we'll go through just some key takeaways and resources. So as usual, the phone lines are muted. If you guys do have any questions, please put them in chat. We will make sure and take a couple stops throughout this to get questions addressed. And if there's any that we don't get addressed, we'll make sure and take them at the end. So that being said, let's take a quick recap of why we should go through and identify devices in our environment. So in our last session, in our Device Resolution 101, we spent a little bit of time talking about why we should go through and do this, if it's even worth our time to identify devices. And I'd say it's absolutely necessary to go through and identify as many devices in your environment as possible. It's necessary to get a complete picture of your environment, as well as to go through and accurately track data, whether that's performance or inventory. There's a lot of different devices in your environment that cannot be discovered via a data source. So physical hosts is my favorite example, right? A physical host, as far as we're concerned, we just see the worldwide nodes of the HBAs plugged into them. So very important we identify those. We'll talk about some of the reasons here. But we may also be capturing switches, storage, tape, anything along those lines that we do not have a data source for. If we don't take the time to go through and identify devices, it can also give us some challenges as far as utilizing OCI. So one of these is incomplete paths. If we're talking about physical hosts, and let's say as an example they have a couple HBAs plugged in, we don't know if these paths are going to the same host, if they're separate hosts. We really don't know what's on that back end. So we don't have any visibility to say that switch is plugged into a physical host through the HBA. We really don't know where that path leads to or what's on that back end. Also, if that host has multipath connections set up and configured, we have no idea without identifying that physical host. We no longer have that visibility. Many of you are running executive level reports or going out and building dashboards that utilize the ability to group different assets. So if you are building anything where you're grouping applications, this can give you some challenges if we haven't identified all of our devices. If we go back to that physical host example, we can no longer group our applications on a physical host basis, which that gives us a much better view of our environment, helps us track down resources associated with the application or the physical host itself. Also helps us track down performance issues if it's relating to, say, one physical host that has multiple applications on it. So a lot of value to be had there. Many of you have looked at the complete topology views where we can see end-to-end views of our entire infrastructure from a host and the application sitting on it all the way down through to the storage. If we don't take the time to properly identify all of our devices, we may not have that complete picture or that full topology view. Also, when it comes time to run those executive level reports, we want to make sure this data is as accurate as possible. And by not identifying devices, there could be some inaccurate data in there. Again, just to go back to that example with the physical host, if we have multiple HBAs plugged in and we run this report, that report might be looking at that as multiple physical hosts. It's not tying those resources together, so really can give us some bad data, and it's very important that we take the time to do this. So,
hey, Kyle, we have a quick question in chat.
Yeah.
Is there any future plan to have some kind of plugin or package which can sit on physical host and discovery is not needed?
Not that I know of. As far as actually discovering and identifying the physical hosts, not that I know of. I will definitely check and see as far as like roadmap updates go, but I don't think that that's something that's on the roadmap right now. A lot of customers, I think, that have a large environment and have a lot of devices that aren't identified through data sources, it's important that you just kind of take the time to learn how to create these regular expressions, because once you've got the concept down, I think it's very straightforward to be able to create these, spend a little bit of time building out the appropriate ones to capture that device information. But there are some challenges there that we'll be talking about today. Does that clear up your question? Okay, thank you. So, as far as resolving the unidentified devices, we're not going to spend much time on this because this is what the last presentation was covering specifically, but we have different options depending on the type of device. Is it a fiber channel device or is it an IP device? If it's fiber channel, we have auto resolution rules, which are used to identify hosts or tape specifically. These are going to use regular expressions or delimiters to extract the device name from an alias. So this is what we'll be talking about today. This is hands down the best method for automating your fiber channel device discovery. You can also do manual identification or CSV imports, which is like mass manual identification. On the IP side of things, this is really a lot easier, so it doesn't really require a separate session to dig into the details. For auto resolution of IPs, it's really a matter of checking a box. For those of you that saw the presentation on Device Resolution 101, you'll know very, very easy, right? Check the box, make sure you have your domain names included, and then it's just going to automatically go out and resolve any of these IP devices using DNS lookup. We can also use manual identification or CSV imports for mass manual identification. Okay, so just to take a quick look here at an example of existing auto resolution rules. So what we're looking at here is our device resolution tab with our auto resolution rules. Down below you can see we've got 2 host rules today and 0 tape rules. This first one you'll see is our zone regular expression. So we've got our source, we have our DNS lookup on, and we have regular expression as our method. We can actually click this link and dive into the specific details of that rule. So just to recap here, at the top, we have our type of device. In this case, we are looking for physical hosts. We have our source of our device name. So in this case, it's our zone alias. We have our method of extraction. In this case, it's regular expressions. You can choose that or delimiters. And then we are doing a DNS lookup. So the DNS lookup is essentially, once it extracts this device name out, it's going to run a DNS lookup to validate whether that device exists or not. You can also turn the DNS lookup on for the preview box below, so we'll talk a little bit about that. Okay, so here in the middle, we can see all of the regular expression rules we've created. So this auto resolution rule is going to work through these 7 different regular expressions, and the order of precedence matters, right? It's going to start with rule number 1 and work its way down to the bottom. So what you'll see over here on the right is the number of matches. So you'll see the first one, it shows 73 out of 121. What this represents is we have 121 devices that have a zone alias, and we captured, or I should say unidentified devices with the zone alias, and we are capturing 73 of them, or matching 73 of them with this regular expression that we've created. Now, the rest of these you'll see in this environment, unfortunately, some things changed around. So these are basically useless 2 through 7 in this example, right? They're not matching anything additional. So if this were the case in your environment, we'd want to go back and change these. So we'll talk a little bit more about that. Okay, down here at the bottom, we've got some details on what's actually being captured. So below, we can see all of the unidentified devices with the source alias as zone. So this is that 121 devices that we were just talking about. Now, it's going to go through and highlight all the different devices that have names captured based on these regular expressions. So you'll actually see exactly what's being captured by looking over here at the extracted device name. Now, in this case, it says host, and that's because we're looking for host. If we'd chosen tape, we'd see that here. But following down this, you can see all of the extracted device names. And this number over here on the left, this represents the rule that is actually being used to extract the device name. So in this case, we know, right, rules 2 through 7 aren't really doing anything. So rule 1 in this case is what's being used to extract these host names. Okay, any questions so far? Feel free to take yourself off mute if you've got one. Okay. So where do I start with regular expressions? What I've done is I've broken this down into 2 sections here. So the first section, we're going to actually go through creating regular expressions and some examples. I don't want to bore you guys too much. This stuff takes some time to go through. So I've got 4 different examples. I want to walk you guys through that, make sure there's no questions. Then we'll spend a little bit of time and jump into how do we actually set up these auto-resolution rules to utilize these regular expressions to extract device names. Okay, so just a quick note here. For those of you that have never done this, haven't actually, maybe you don't do any coding or such, you might not be aware of what regular expressions are. So basically, it's just a pattern used to specify a set of strings required for a particular purpose. So in our world, let's say we're talking about OCI and device identification. It's a method that we use to go out, look at a string, in this case it's an alias, locate a specific set of characters within that string and extract them out. Okay, the specific set of characters we are looking for is the device name. So a lot of this is going to come down to how you have created your aliases, your zone, your switch, or your storage alias, right? If you haven't created those, and we don't have an alias, or we do not have the device name in the alias, then we basically need to stop here and go back and include that information in those aliases. Otherwise, we really cannot use any method to extract the device name because it doesn't exist in that alias. Now, if we do have that, it's pretty straightforward. So what you're going to see is regular expressions. They are very powerful. So they can be incredibly broad. You'll see this example of dot asterisk. This will grab every character in a string. So if we're talking about an alias, it's going to grab the entire alias name. Most cases, this is useless, right? Usually, an alias is going to contain a couple different names, whether that's a zone name with a host name, with a switch name, HBA, drivers, right? There's different things that you may include. So regular expressions are awesome because we can fine-tune these to find exactly what we're looking for, whereas something like delimiters is a little less flexible. Delimiters really only allow us to choose a certain number of characters between, say, a hyphen or an underscore. So let's start with some of these basics. So the parentheses is probably the most important thing to be aware of when you're writing your regular expressions for device identification. The parentheses indicate that the characters we're capturing within the parentheses, these are the ones we're extracting for the device name. So when we go through and write these, we're trying to match as many characters in the alias as possible, but only a certain set of characters is going to represent that device name. So as we write this, we use the parentheses to basically indicate that and extract those characters. You'll see a little bit better when I get into an example here. The period, this is a wildcard that's going to match any character. The asterisk is going to match the preceding character, or I should say preceding bracketed characters, 0 or more times. So at a very, very high level, let's say, for example, we have this TRE asterisk. Now, if we go through and we run that against, let's say, 3 different words, tree, tread, and trough, it's going to actually find all of them because the preceding characters all happen 0 or more times, TRE. All of them include that, except for trough, but it includes TR, and then that's that 0 times, right? The E does not occur. So all 3 of those will pass. Now, the plus sign, on the other hand, matches the previous character 1 or more times. So TRE plus is only going to find or match tree and tread, but not trough. That's because of the O, right? Has to be at least 1 or more times. The question mark, this is going to match the preceding character 0 or 1 time only. So this one's a little different. So let's say, as this example says here, we're looking for color, but we know color can be spelled a couple different ways. So we put the question mark in there after the U. Now, if we do that, it's going to find both color with OR and color with OUR. Right? Now, any questions? I know this is a lot to consume. I think it'll make a little more sense as we move on to some examples here. But any questions with these before I move forward? Okay. So example number 1 here. We've got a zone name up top, S0422 underscore my computer 1 name underscore HBA3. So what I've highlighted in green, this is our host name. All 4 of these examples, we're going to be extracting physical host names. And I've highlighted them in green. So what we need out of this entire zone alias is my computer 1 name. So below this, I've got the regular expression that we would use to capture that name. So the S represents the zone name, and that begins the expression. The characters in the brackets, so brackets 0 through 9, this is going to indicate that the S must be followed by a digit between 0 and 9. The plus sign, this indicates that the information within the preceding brackets must exist at least 1 time. So that would work for S0, S04, or in this case, S0422. Now the underscore indicates that the digits that follow the S must be followed by an underscore. So if, say, a letter followed that, we would not have a match. But in this case, an underscore follows the numbers, so it moves on. Now the parentheses, this again indicates that the pattern inside of the parentheses is what we want to extract. This is our device name. In this case, this is the my computer 1 name. Okay. The bracketed characters within the parentheses, so the A to Z, capital A to Z, and 0 through 9, this basically says that the characters are being matched are either letters, which can be uppercase or lowercase, or numbers, or numbers, I should say. And then the plus sign indicates that the characters must occur 1 or more times. So the bracketed characters with the underscore dash, this indicates that the alphanumeric pattern previously must be followed by an underscore or a dash. So when you see these brackets, think of this as kind of like an or statement, right? You can have anything in there. So over on the left, 0 through 9, it can be any number. Over here on the right, it can be the underscore or the dash. We really don't care. It's one or the other. The letters afterwards, HBA, this indicates that it must specifically match that order because we do not have brackets around HBA. It must follow that to the T. So if we had a lowercase HBA and we had case sensitive turned on, right, this would not capture that. The final set of bracketed characters here, 0 through 9, they're going to match any digit 0 through 9. So in this case, the number 3. So with this regular expression, we are able to extract my computer one name. Okay, any questions? And some of this might take a little bit to consume, so keep in mind I will be sending this out. Did I just get, let's see, okay, got a question in chat. So the question is, in the bracket underscore dash, could it be any possible character or some special character? So in this case, it can only be one of those two characters. So once you put in the brackets, unless you indicate, say, a wildcard of sorts, we're not going to be able to find anything aside from what is specified in there. So you'll see, if we just jump back here, this first set of brackets, 0 through 9, it has to be a numeric digit anywhere from 0 to 9. And the plus sign here indicates that we can have multiples. Now, in this case over here, the underscore dash, it can only be one or the other. And it has to be followed by HBA. So we can't have both. We can't have a combination of, say, 2 or 3 of these. It has to be one or the other because we've specified that. Does that clear your question up? Okay, perfect. So in this example, we want to extract from the zone name the my computer name 123. Now this one's a little bit more straightforward. So this is what I have seen in some environments myself when I've been helping customers out, where the host name might be right at the very front, and it's followed by a lot of things that really don't matter as far as that device identification goes. So this one's a little bit easier. So first off, we know that the first thing we're extracting is the device name, so we want to use parentheses on the first set of characters to match. From there, the bracketed characters A to Z, capital A to Z, and 0 to 9 indicate that any letter or digit, regardless of case, can match the name of the zone. Okay, the plus sign indicates that the bracketed characters must occur one or more times. The underscore character indicates that the zone name must include an underscore, and that underscore must immediately follow the alphanumeric string that matches the letters and digits that are enclosed in the preceding brackets. Okay, so this is where it gets really easy. The period matches any character. It's a wildcard. So anything after that underscore, and then the asterisk is going to indicate that that preceding period wildcard, can occur 0 or more times. So that's really nice, right? If we had nothing after my computer name 123, we're okay. And if we have a lot of things after it, we're okay. As long as we know that that physical host name is that first set of alphanumeric digits before the underscore, we can now capture this. So pretty straightforward. Okay, any questions on that one? Run a little low on time, so let me go ahead and push through this, and then if you guys do have questions, I want you just to follow up with me directly. I will make sure we walk you through any of this, and I have a lot more examples I can get you as well. So in this case, this is a very easy one, right? We've got my computer name followed by a string that is identifying HBAs, storage arrays, and such. In this case, we want the physical host. So parentheses, again, indicate that the first pattern we match here is what we're actually looking to extract. Now, the period asterisk matches any character, any number of times. This is where we introduce the question mark. This is basically it's going to force it to stop matching at the first underscore rather than the last. And then the characters underscore dot asterisk matches the first underscore found and all characters which follow it. But again, the parentheses indicate which one we're extracting. Okay. And then zone names here. So this case, we've got 3 separate zones. You'll see they're all following a similar naming convention, but they're a little bit different. So what we're going to do is start with a period asterisk to match any character any number of times, followed by a question mark to stop matching at the first underscore rather than at the last. Okay, the underscore matches the first underscore in the zone name. So that's leading up to the apple, banana, and pear. Okay, then the parentheses indicate this is what we're looking to extract. This is the device name we're looking for. The bracketed characters, again, any alphanumeric number. Plus sign, again, just indicates that those alphanumeric characters must occur 1 or more times. Okay, the underscore that follows the parentheses indicates that letters or the alphanumeric string before must be followed by an underscore. And then again, we've got the period asterisk to say we can match any number of time. Okay, got one question here. All right, question is, if there is a server name followed by a random string separated by underscore, then what expression suits that? I have to create multiple regex for each number, or else it doesn't work. Sunil, will you do me a favor and follow up with me afterwards? I know we're a little low on time, so I'm going to try and push through just the last bit of this, but I can absolutely help you out with that. Okay. All right. So since I've wasted a lot of time on creating these rules, I want to just quickly run through the process of creating the auto-resolution rule, which uses these regular expressions. So goal here is to automatically extract the device name from an alias. What do we need? We need to know, first of all, are we looking for a physical host or are we looking for tape? Then we need to know, where does our name reside? In the storage, switch, or zone alias? And then in this case, we're going to use regular expressions to capture that. Okay, so we'll come into our device resolution. We'll come over here to add new rule. Okay, we'll start out by typing in our regular expression that captures what we're looking for. Keep in mind this example, it's not, I don't think it's all that great. Unfortunately, it's the lab environment that I was working with and had available. So you plug in your regular expression. Okay. First off, we've obviously defined the type of device as a host, the source of device name as zone, so we're using the zone alias. We are using regular expressions, and in this case, we are using DNS lookup. We want to go out and validate that. Okay. One note here is we will create separate auto-resolution rules for each type. So if you're doing host or tape, we're going to have different ones for each. And then for every source, so zone, switch, or storage alias, we're going to create a rule for those. We don't want to mix those. We can't. Okay. Now we're going to come in here and plug in our regular expression. Now this format, this is something important to call out. /1 means it's going to grab what's in the first set of parentheses. If for some reason you need to combine multiple characters that aren't, say, consecutive from an alias string, then we can actually use multiple parentheses and do like a /1/2, even a /1/2/3. That's just going to capture the different sets of parentheses. We can choose case sensitive. And then over here, you'll see we have 24 devices that have a zone alias. We match 16 of them with this one rule. So that's all great. We can see below all the ones that match. We can see the rule that they're matched from. And over here on the right, we can see the name that we extracted from the zone alias. Now, this is all good, but what if we want to get as close to 100% as possible? Well, we now go back and we say click add, and we'll create another regular expression. So in this case, we'll go through and create another one that will find more matches. Now in this environment, It's kind of messy. The remaining 8, honestly, don't follow any consistent naming conventions. So I would have to go out and create 8 separate additional rules, or I could do manual identification. In large environments, you're going to see usually rule number 1 is going to cover as much as possible, but typically not near 100%. So you may get up to 60%. In that case, move on to rule 2 and capture as much as you can with that, which that can come down to, say, 25%, and so on. Okay. From there, make sure to hit save. Don't want you to lose all of this. And then most importantly, we have to run this. So best practice, set your auto-resolution schedule to run every day. Really just have it run every day at midnight. That should suffice, unless you're in an environment where you have a lot of changed devices or a lot of new devices being plugged in and you have to run it more often. And then we can come over here and we can run this manually so we get those updated immediately. Okay, going to just run through this. We basically aim for 100% device identification in a perfect world, but it's not a perfect world, right? So let's just get this number as high as possible. Call us if you have any issues, your customer success team. Use separate rules for each device type and each alias type. And then go through and play with a different combination of regular expressions to capture as many of those devices as you can. Okay, I've got some really good resources here worth your time to check out. I will be sending this out to everyone. And the Documentation Center does include a lot of great information on device resolution and regular expressions. It has probably 6, 7 examples in there that I did not go through today. So hop over there, take a look. I'll include a link on the email we send out as well that has some other regular expression examples, because this can just be a tricky thing that requires some practice. With that being said, thank you guys so much for taking the time to hop on. Apologies for running over there. If any of you do have any questions, please stick around, and if you have the time, I'm happy to chat with you right now. And if you don't have the time, you guys have to get back to your day, shoot me an email. Send your questions over to our team. We'll make sure and get them all addressed. Thank you guys again. Appreciate your time. And thanks, Joy.
Thank you very much, Cal. It was a great session. Thank you all for joining, and we'll join you again next time. Thank you.